All right, we're live. February 21st. Today's challenge, Sunday. Well, before we go into it, take a look. Anything that I remember. Find medium from data stream. I don't remember even doing that. Oh, I actually remember doing that. It's not a simple question. Anyway, let's take a look at today's challenge. Broken calculator. Broken calculator. Let's see. On a broken calculator that has a number showing on its display, we can perform two operations: double, which is multiply by 2, or decrement, subtract 1. Initially, the calculator displaying the number x returns the minimum number of operations needed to display the number y. Why is it called broken calculator? Just a calculator that can only do two options, either double or decrement. I've done something similar. It's like if it's an even number, you divide it by 2. If it's an odd number, you decrement by 1. But apparently this is slightly different. It says you can double it or subtract by 1. So from 2 to 3, I would double it first and divide by 1. Divide by 1, minus 1. Yep. 5 to 8, minus 1, then double it. Okay. 3 to 10, well, you double, minus, you double is, yeah, you double it to 6, minus 1 to 5, and double it again. 1, 0 to 4, you have to decrement operations. Hey, why? Why? Why cannot you just, oh wait, to bring it down. Okay. I think we'll find something interesting here. If x is larger than y, then the only way to do is decrement, because you cannot double. The double, you just make it even harder. You have to use more steps. So the only way is to decrement. We'll actually take a quick look to check. Let's see. I think I can actually. I don't think I can do it here. Anyway, just give a random number, and that has to do what, 449 steps? 449. Let's see, that's 449. 450. I thought it's, oh yeah, 450. What I'm thinking, yeah, it's divided by 1. Okay, so that was resolved. I think we can do any number. And then it'll show you it's 46540. Yeah, so we solved that. Now, when it's smaller, that's when we have to think about. When it's smaller, from an analytic point of view, if I double it and it's still smaller, I need to double it first. So I just keep doubling until it's going to be bigger. So I just double it and double it until it's bigger. We'll double it until a number that is small. That we double it until a number whose double is larger than y, and then we stay at that value. And then we know double it will be larger than y, so we decrement it. We decrement it until we hit a value that once we double it, it's going to be equal to y. So let me see if it's possible to express this in a mathematical term. So basically, we say x times 2 times 2 times 2. So 2 to the, let's say, k power, and it has to be 2 to the kth power. It has to be, let's say, equal to y, right? And then we get the k, and then we take the integer part. So we take the integer part of k. So we have k, and then we are going to compute the value. Hold on. We can actually go above. So we take the integer. We take the, what's that? The ceiling. Yeah, I think we'll take the ceiling of this k. That means that is the smallest k, the smallest number of doubles that can make x larger than y. So now x is over y, so we need to bring it back down. But because we double it, so every time we bring back down 1, it's actually bring back down twice. Does that make any sense? Actually, it doesn't make any sense. Okay, let's go examples 2 and 3. So I say I'm gonna times 2, so I go once. Okay, so now it's 4. So we're gonna bring it back down once to 3. Okay, that's bring it back down once. 5. If I double it, becomes 10, and then bring it down. So when you bring it out twice, then that actually give us. So that is the issue, right? How do we determine? Because we know 2. So 2 is already 5 is already at that point as well. So 2 we know if we double on 2, it's going to be bigger. But if we minus 1, double on 1, it's going to be smaller. So we have to double on 2. 5, if we get smaller and then double, we can reach 8. 3, we have to double to 6 because it's not larger. And then from 6, we can double again, but that'll be 12. And then we want to minus 1, but every time we decrement 1, we actually, so when I'm bigger, because from 6, if I minus 1 and times 2, the final effect is minus 2, which means when the value, when I double the x and it's bigger than y, now there are 2 choices. We can take 2. Every time we take 2, that's actually minus 1. The stepwise. But we can also, of course, take only 1. So, for example, 2 to 3, we double 2, we get into 4. And then between 4 and 3, we have only 1. It's an odd number. So basically, it is like whether it's an odd number or an even number, right? Not really an odd number, an even number. If it's an even number, the result is the even number divided by 2. That's the number of steps we have to decrement before we double it. If it is a odd number, then we have to do one time, and then the other can be the doubles, the multiplier 2. All right. Okay, so now it's just me talking. I'm kind of forming this thought. What is also important is to see if we count the final double, right? So for 5, do we count so we can count it and then we count decrement. Yeah, because if we go down and then we go up, it's the same as we go up and then go down. So we count this go up. So we always count the go up. Let's give an example. Let's say we have 3 and 101, right? It's a very weird number, 3 and 101. And use our idea and see if it works. So my solution would be we first find the k. So I take out a calculator. We first find the k. That's the minimum number of times you multiply 3 by 2 that can become larger than 101. So what we're going to do is 101 divided by 3, and we do a logarithm of that. So we're going to log 2 on it. So we get is 5.07. That means 3 times 2 to the 5.07 power equals 101. And we take a ceiling of it, so we're going to do 6. So we have 6 steps, which means 3 times 2 to the 6th power will be the smallest number that is larger than 101, which is 192. We can actually double check. If we do 2 to the 5, it's 96. So yeah, that's correct. So we have 6 6 times. We go to, I forgot, what's the number? 3 times 2 to the 6th power is a 191. So between 191, we get minus 101, which means the difference is 91. So we know it's an odd number, so we're going to do an extra step, right? So we minus 1, that one has to be done no matter what. And the remaining 90, every time we decrement once, it's actually counted as 2 values. So we divide by 2. So this gives us 45. So eventually, the solution should be 6 plus 1 plus 45. So it's 52. Let's see if the answer is 52. Ha! It is not. I was so confident. All right. It is not correct. So this way of thinking is not right. All right, let's see. It says 11. Okay. Ha. So we know we need to keep doubling. Let's change the idea. Apparently, the last double is not necessary. So let's do 5. Yeah, I think this idea is not right. Let's do 5. So 3 times 2 to the 5th. So we just keep doubling, and this gives us 96. This gives us 96. And if we double 96, we know it's not going to be correct. But how are we going to actually do this? We are going to decrement from 96. Oh, we don't decrement from 96. Hold on. So it's not going to be 5 because it's too big. 96 double is too big. Let's get it even smaller. So let's say 3 times 2 to the 4th is 48. 3 times 2 to the 4th is 48. And 48. Hold on. It's not working because you're starting from 3, right? And that's why it's not working. Probably need to change your starting position because now I'm at 48. What am I going to do, right? I double it. It's 96. It's not. And if I double it again, and it's too big, and I have to take a dramatic number of. Basically, I mean like from 96 because it's too big. I want to go down to 50. All right, 96 go down to 50. We have to take 46 steps to go down to 50. And then we're going to double from 50 to 101. It's actually not 50. We're going to go down to 51. And then we double to 102, and we go down 1. So that was my solution. But apparently it's not correct because the expected answer is 11. It's much less than my expectation. So apparently, because we cannot do any other doubling, we double it twice, 6. It's not going to work. We double it again. Which means we probably need to what if we change 3? So instead of we're going to start from 3, we're going to start from 2, right? If we start from 2, basically we need to get to a value. We need to get to like 50. If it's 101, we need to get to 102. We need to get to 51, right? To get a 51, we need to get a 25, 26, right? And to get a 26, we need to get to 13. And to get to 13, we need to get to 7. To get a 7, we need to get to 4. And to get a 4, we need to get a 2. I think that is the solution, right? So we're going to do 3 to 2. I'm actually just type it out, right? So what we're going to do is we're going to be going from 3, and we're going to go to 2, go to 4, go to 8, go to 7, go to 14, go to 13, go to 26, go to 25, no, not 25, no, 25 is directly 52, go to 51, go to 102, go to 101. So that's what. How do we count the steps? Okay, excluding the first number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Boom! I think I find the trick. So the trick is to get to 101. Right? It is the most, and my current value is small. So the most efficient way to get a big number is to double it. And 101 is an odd number, so we cannot get here. So we can either get to 100 or 102. But since we can only decrement, so the only way to get to 101 is to get to 102. And to get to 102, we use doubling, so that gives us 51. And then 51 is an odd number, so we do the same trick. We need to get a 52. And from 52, we need to get it to 26. And 26 is an even number, so we can theoretically go from 13. 13 is an odd number, so we need to go from 14. And 14 leads to 7. And 7 leads to 8. 8 leads to 4. 4 leads to 2, and 2 leads to 3, right? I think that this is also 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we can actually go from the top, from y back to x. Basically, if it is odd number, we plus 1. If it's even number, we divide it by 2. Odd number plus 1, even number divided by 2. Divided by 2, plus 1, divided by 2. If it's bigger, it's always plus 1, divided by 2, divided by 2, plus 1, and we reach it. All right, I think that is the solution. Let's get on with it. It's an interesting question. It's as the LeetCode community likes to say, it's more of a brain teaser. I think the implementation will be fairly straightforward. Again, with this type of question, I always go with the programming route first, and after the programming route, I'll probably try to see if there's any math way we can do. So I'm gonna rest set it to, I just call it steps, it'll be easier to understand. And then we just say while y is not equal to x, we're gonna change y, and we're gonna say if y is an even number, we're going to do y plus equals 1, else we're going to do y divided by 2, and we're going to do steps plus equal 1. This, I think I can do it in one line. Oh, I probably cannot do it in one line, but you know what, I can. So y plus 1, if, and else, just put proper parentheses, and I'm going to return steps. Once I reach it, and that's the end. Might be steps minus 1, I'm not sure, but this we can fix at the end. So let's put in our test case. We have 2, 3. Oh, did you consider that when I forgot when x is large. Oh, and that's in this case. No, it's gonna get stuck. So I'm gonna say if x is larger or equal to y, we simply return x minus y. Yeah, and that shall work. 5 to 8 gives 2. There is also 2. So next is 3 to 10, which is 3. Next one is 1024 to 1 is 1023. We actually also have a 3 to 101, which gives us 11. And we're going to fix here. It's going to be x, y. Solution will be broken calculator, x, y. And I'm going to run it. And I hit a... I hit an infinite loop. Why is that? What is that? So what is 3, right? 3 not equal to x. Okay, so 3 is an even number, so 3 plus 1. And then it becomes 4. 4 is not equal to, and 4 is here. So equals 2, come up, and then they equal, then I can return. All right, let's see which one actually caused the problem. Yep, this one passed. Oh, it's the second one that's causing me a problem. Oh, okay, Control C. Y causing me a problem. So y is 8. Oh. 8. I divided by, it's smaller. Shoot. All right. Shoot. Why is that? So 5 to 8 is not working. How about this? This is working, right? So divided is 5 plus 1 divide. Yeah, this one's working. And 3, 101 is working, but 5 and 8 is not working. Probably 6 and 8 is not working. So like they're too close to each other. Why is that? Why is that? So 8 divided by 2 is 4. Once it's 4, y becomes smaller. Right? And in that case, so shouldn't it be while y is larger than x? Because when y is smaller, I divided by 2, is smaller, and I want to get to 5, I just need to add 1. Then I become 5. But I cannot do because now I'm 4. I am actually... Hold on. Let me think. What I mean is, throughout this process, y should always be larger than x. Only when y is larger than x, we're doing this. Because we're trying to bring y down. Because from x to y, we can only decrement or double. So from y to x, we can only increment or divide. And if it's an even number and it's bigger, we divide. If it's an odd number, we plus 1 and then divide. But once we divide to a certain point, the y will be actually smaller. So when y is actually smaller, we just do x with decrement from x. We just increment. But that is a different strategy, which means I should say while y is larger than x, we do all this, and we have all the steps, right? And when it exit, which is plus, so we know y this time is smaller or equal to x, so it's just x minus y. And this one pass. What did I do? Oh. All right, let's see. Everything works. Let's try it. Submit. We did it. All right. Lo conseguimos. Should be pretty good performance. Hope. Yeah, pretty decent. All right, this is not a straightforward solution. We have a little bit trouble. So how should I name it? We should say that I mean, we can do it the other way, right? We don't have to say we go from x to y. We don't have to say that we're going from y back to x. We can also say that we're going from x to y, because from x to y, the only way to go is -1 and double. Oh, but the thing is, from x to y, we don't know if we need to minus and to double, or we double directly, right? That option is not clear. We can double it, or we can minus then double. But the option on the opposite way is very clear, because from x to y, we can definitely go from y to x. Now from y to x, the option is clear because only thing we can do is +1 or divided by 2. Now, divided by 2 is not possible when y is an odd number. So whenever we see a y as an odd number and it is bigger than x, the only way to bring y down is to turn it into an even number, which is +1, and then divide it by 2. Exactly. So this is our reason. We know from the beginning that if x is larger or equal to y, then the answer is trivial, which is x minus y. If x is smaller than y, it is harder to reason from the perspective of x, because x can either double or -1 and then double. We are not sure which direction, which way to go. On the contrary, if we look through, if we see the problem from the perspective of y, it becomes very clear, because y can only +1 or halve. Since an odd number cannot halve, it is deterministic that y either halve when it is an even number, or +1 and then halve if it is an odd number. So we can bring y down to x. Now, y can be brought down to exactly the same as x, and we're done. However, it is also possible that y is brought down to a value lower than x. In that case, we are actually in the first scenario, and the solution and the additional steps would just be the difference between x and that value smaller than x. So I think the runtime, because we're dividing, so the runtime is log y, and we are having 28 milliseconds with 86% ranking. Okay, so that's our solution. I am thinking whether we can do this, say like in one line. Because it's incrementing, so we can use sum, right? And as we're doing this, probably not. We are changing y. And you know what? I like how it looks like. Let's take a look at any possible solutions and how the other smart people are thinking about this. Oh, maybe an easy question. I have a solution here. Let's see which problem it is. Number what? 991 is a medium question. We solved it, so we give it an upvote. We try to upvote every single question because we hope that we can solve every one of them. So LeetCode 991. All right, I think the first solution is the same as ours, so we're gonna work backwards. Yes, that's exactly the same as ours. Oh, that's the only solution. It consider this as a greedy solution. Always greedy divided by 2. Okay, it's gonna perform one addition, one division, or whatever that means. Yeah, when y is larger, at 1 if it is odd. That's what we need to do to add addition. Yeah, that's true. How does one come up with such a concise answer? I just did. Well, you come up with this by experimenting with a wrong solution. You're trying to go from x to y, and you're trying to double, and then you realize that doesn't work. And then you have the intuition that going backwards is more deterministic, which they say is actually greedy. And it's not really greedy in my opinion. It's not really greedy. It's just the only way, right? From y coming back to x, the only way is either +1 or divided by 2. And we know if x is smaller than y, you cannot go from y to x by addition. The only way is division. And because throughout the entire process, it's always going to be integers. So it's impossible to divide when y is an odd number. So here you go. There's no greedy. It's just pure math. You have to +1 and then divide by 2. All right, so that is the intuition to go from y back to x. But people do have this question. I thought the same as from, and then spend a year how to optimize. BFS. I don't even know how to solve this BFS. All right, we actually found the optimal solution. I do want to see some BFS. Let's see what people say. Let's read. Explanation. With subtraction and multiplication, the effect of earlier subtraction will be amplified by later multiplication. Hence, greedily doing multiplication might not reach optimal solution, as an additional early subtraction can have a huge effect. That is true. Whereas with addition and division, earlier addition will be diminished by later divisions. It is thus always better to do division whenever possible. Isn't this solution against the spirit of the problem, not a real-world application? Come on, man. Don't even think about this. I'm going to leave a little comment. All right, we can also think about it without considering greedy. I think about completely based on how numbers work. How should I phrase it? I'll think about it this way. From x to y, the only way to go is either subtraction. All right, I'm going to use the symbols. -1 or times 2. Therefore, no. Any such path leading to, I'm going to increase the length. I cannot see what I was typing. Any such path leading to y also means that there exists a path from y back to x through +1 or divide by 2. The key is that going from x to y is not deterministic, because one can choose to multiply 2 or divide it, well, -1 first and then 2. However, going from y to x is deterministic, because we cannot do divide by 2 when y is an odd number. Therefore, whenever y is an odd number, the only thing we can do is +1 and then divide by 2. Therefore, going from y to x is straightforward. All right, I'm going to leave my comment here. Probably not going to show up. They will show the one that with the most upvotes. I want to see if there are any other. Changing y to x in one line. All right, let's see. Oh. No. No, I don't even want to read it. Oh. Oh yeah, this person has already said it. Ah, I felt stupid now because somebody's already said it. All right, so I am not going to do this. Oh, diff, that is too complicated. Recursive one line. If x, all right, else 1 plus, that's either 1 or this. Oh, nice, nice, nice. So, yeah, this is one of the tricks I see all the time, right? To determine whether it's even or odd, we can just do this, because if it's odd number, it's just +0. And you do this, if it's an even or odd, the result is the same. Wow, applaud, applaud. Good solution in one line. Good solution. No, I don't want to implement it. I like how mine look like right now. Detailed proof. Let's see. Oh my god. Oh my god. It's so. Oh my god. It's so long. My goodness. All right. I'm gonna probably read this later. Yeah, I want to see. Like it's a greedy. You can. This is greedy, but no, kind of approach it from a different angle, from a arithmetic angle, a mathematical angle. But at the same time, it is still a greedy, right? They're still greedy. So whenever there's a greedy, you have to prove it. This guy does it every day. Anyway. Plus 1 divided by 2 divided by 2 plus 1. All right, he has a proof as well. I'm gonna look at two proofs, but you guys can look at proof yourself. I'm not gonna waste time here, so I'm just gonna end it here very soon. Oh, before I end, I listened to the Python Bytes podcast today, and they talk about they have Brett Cannon on it, who's on the Python development steering council, and also I think he works for Microsoft on the VS Code team. So previously I mentioned about the new feature added to Python 3.10, which is the pattern matching, and then there have been a lot of discussions on both sides. Some people like it, some people don't. Well, I have said it before. I love it. I think this is one of the best things. And Brett mentioned that the people on the steering council, they did see all those discussions, and they feel just he had a good rant out there. It's like they're doing this job, they're doing all the work free of charge, right? They didn't get paid for doing this. It's an open source project, and then you just have all these people coming out and say this is not how you do it, and you should do it this way and this way and this way. And then it just like seems to those criticisms, like the criticism they have towards this decision. A lot of them say it's like, is this like think of out of a whim, right? It's like a sudden change, and there's no discussion. Like this kind of people's perception of this, but it's actually not. This idea of adding, according to Brett at least, and actually some of the material I read online, this idea of adding pattern matching came from Guidor a long time ago, 2 years ago, right? So Guidor thought about it 2 years ago, and then they started implemented about half a year ago, so more than 6 months ago. So Guidor is the one behind pushing this, right? So it has been in the pipeline for a long time. So this is not something that just out of a whim, something like people say, oh, because Rust has it, so Python needs to have it. No, I don't really think so. I think this is something that has been planned very well and then has gone through a lot of changes. And just to think that they have 3 PEPs, right? PEP 634, 635, and 636. 3 PEPs about this change. That means this has been thought about very carefully. And people are arguing it's not Pythonic or whatnot. Well, argue with Guidor. I mean, if his decision is not Python, I don't know whose decision is, right? So, I mean, at the end of the day, people don't like to change. I mean, this is what I see out of this. People just don't like to change. They like the way how they write code, and then new things come along. Some of them just have a resistance to change. But eventually, I think people will be fine with it. I mean, Brett also mentioned a little bit controversy in the past when Python introduced true and false, introduced Boolean values, which people don't like it. I mean, at the beginning, I mean, now we think about it, it's pretty dumb, right? Why would people not like it? And the reason is simple, because the Pythonic way is if you have one way to solve it, you should always use this one way. And because 1 and 0 can be used, and actually is already used in Python to implement truthy value and falsy value. So why do we need 2 Boolean values, true and false, right? So that was the argument early, like many years ago. And then there have been a lot of back and forth, and then finally people settled, okay, we can allow it. But now looking back, like so many years later, looking back, like this is a silly argument. Why would we not want it? So it's just like some people have their view of the language, right? And then they don't like how other people change it, and they just feel angry, and then they start criticizing the new things. But at the end of the day, like this language it's not just for like this people, right? It's for many people. It's a general purpose language, and you can speculate the reasoning behind it, but the actual reason is just this is a good feature to have, right? It's a feature that the language lacks, and then it solves a real problem, right? It's not switch statement, it's pattern matching. It's a lot more powerful than your if-else statement. Again, this is a godsend. It's a great thing. I hope that this thing can just keep evolving and then eventually it can roll out. I'll be very happy to try it, to use it. So anyway, so that's a little bit to end today's challenge. And all right, we'll see you guys tomorrow. All right, a new day tomorrow. Adios.